Julia Kodysh was a lead on the data infrastructure team at the COVID tracking project, focusing on internal tooling and data processing. In her parallel life, she's a computational scientist at Mount Sinai, working on cutting-edge personalized cancer immunotherapy clinical trials. Julia's prior experience includes leading a team as a data engineer at Oscar and working as a senior software engineer at Google with a focus on data infrastructure and healthcare-related initiatives. Julia holds a Bachelor of Science and Master of Engineering in Computer Science from MIT.
Thanks so much for the intro. Hi, everyone. I'm Julia Kodysh, and I was a data infrastructure lead at the COVID tracking project. So today I'm going to talk a little bit about this organization, what our goal was, a bit of the story around it, and I'll also go into some technical details about our work. So the COVID tracking project was a largely volunteer organization. We collected state-level COVID-19 data. And we did this for 365 days, starting March 7th, 2020 through March 7th, 2021. We stopped because we felt that federal data had improved enough over the course of the year that we felt confident that we could do so. So we focused on several categories of data collection and presentation. Our core data set, which is what I'm showing here, was testing and outcomes data. So this included COVID tests, cases, hospitalizations, and death counts. So what I'm showing here is a 4-up view that we produced every day. We also worked on a COVID racial data tracker, which was testing and outcomes data broken out by race and ethnicity. And this let us show the disproportionate effect that the pandemic was having on certain communities. And then lastly, we also track COVID data as it related to long-term care centers, like nursing homes and assisted living facilities. So each of these efforts was huge. In this presentation, I will mainly focus on the infrastructure behind the testing and outcomes data, since that's what I focused on at the organization. So I'll start with a brief description of our data collection processes, and then I'll go into how we stored and served and ultimately presented the data to the outside world. So our data collection was ultimately manual. We got our data directly from state and US territory dashboards. In the beginning of the pandemic, that was basically the only place to get it. And the process that we'd settled on as a group was collecting data into a large and structured Google Sheet, which looked something like this. The data entry team would organize work in structured shifts, and then these would end in a manual process for publishing data for that day that would make it ultimately go live on our website and our data API. So the important thing to note here is that every single published data point was verified by a human being. So I want to start with kind of an obvious question for a project like this. Assuming that we're regularly collecting data from over 50 websites, why not just scrape and automate the whole thing? So the short answer is change was the only constant. Unfortunately, the data landscape that the COVID tracking project operated in was a pretty substantial lack of consistency or standards in COVID data reporting, especially early on. So things change really, really often. There were changing dashboards, and to begin with, many of these dashboards actually kind of seem designed to obfuscate or at least be hard to scrape. More generally, kind of over time, there were lots of changes to the data formats that we saw, and also to the metrics that are actually being reported. And then what's probably the hardest thing to cache automatically, there could be changes to the meaning of a reported metric part of the way through. So even if we'd set up a perfectly automated system on day 1, it would be wrong by day 5 in myriad ways that are hard to impossible to notice with automated checks. So you still come back to human scrutiny being a core part of the process. Ultimately, we decided that we needed our eyes on data annotations and context, at least at some point in the data pipeline. So this is just one example. It's actually one of the better ones. So this is Rhode Island's COVID data dashboard from July and September of last year. Over the space of those 2 months, you can see that they changed the dashboard layout. This is not at all to call out Rhode Island as a state. They're actually great. They provided a really, really good data sheet with all the data available. But in many other cases that would look like this kind of formatting change would also come with a change in the data export, assuming that a state website even supported data exports, which was often a very big if. So data collection had to be manual so that we could trust our data, which was the most important thing. But we ended up building increasingly strong crutches around our data collection process over time. So one system that I want to mention here is we created a website screenshot framework. You can kind of think of it as a very domain-specific Wayback Machine, where we would take automated regular snapshots of state COVID-19 data sites. We did this for a bunch of reasons. Firstly, data provenance. It was very, very important to us to be able to show our work where the data came from, which is very closely connected to data quality. So we needed to be able to go back and check our numbers against what had been published by the states on specific dates and answer questions like, how many cases did, let's say, New Hampshire report on March 30th? And also, how do they show that data, which gets us into data annotations. States would make changes to data definitions on the regular, and this kind of context had a good chance of being reflected maybe only in a visual version of the website, as opposed to something like a data CSV or metadata. In addition to that, screenshots also helped us maintain history. So this was particularly useful for situations where we needed to update our data in response to retroactive state data revisions, which happen all the time. And having older screenshots helped us keep track of what the states themselves were putting out. And then lastly, we did this for archival reasons. So eventually we want to be able to present a record of what was reported and when, and to have that record be as complete as possible. So this is a quick tech overview of the system that we made, which captures state websites and does a little bit of sneaky scripting to navigate to the right data points. So in a nutshell, we had a Python script, which ran as a cron job several times a day to collect screenshots. At first it ran on a personal laptop, and then at some point we decided that we needed to be grown-ups and moved it to an Amazon EC2 instance. So the script used a cloud service called Phantom.js Cloud to render websites and capture screenshots. And also it let us, Phantom.js Cloud supported various custom JavaScript to navigate around before taking a snapshot. More on that in a second. So all of these customizations ultimately lived in YAML configs on GitHub. In general, we were a very GitHub-centered org. All of our code is actually still up on there. And then ultimately, we stored screenshots on S3, and we made them accessible on our website. We found that Python lends itself really well to this kind of thing. Most of our code was in Python. It's easy to quickly write readable scripts, and there's good library support also for things like S3 and also Slack integration. It's not pictured here, but we integrated with Slack to alert us to screenshot failures. So this is an example of a state screenshot config. It's structured to our use cases, so it has a URL, some web browser settings like page size, and a message that we use to remind ourselves roughly what this config is doing and why we needed it in the first place. The interesting part here is this bit in the middle called the overseer script. This example is definitely not the most complicated thing we had to do, but really often we would need to do stuff like click on the 5th tab of this dashboard, which of course doesn't have a reliable selector name because why would it? So we click on the 5th HTML element of this type, then wait 49.3 seconds for the page to load, click our heels, spin around 3 times and hope for the best. A lot of the time this worked, but sometimes it didn't. And in cases where it did not, one of our awesome volunteers would take a screenshot manually and put it into our screenshot store. So along the way, we ended up basically building an accidental brain trust of automatically navigating around ArcGIS and Power BI dashboards. I just want to say here, this seems an awful lot like automating data collection, but for the reasons I mentioned before, where things kept changing, we couldn't fully replace our human processes. We considered it at multiple points and decided against it. So screenshots were ultimately a best effort project where our competency around scraping Power BI lagged behind our core competency around COVID data collection. At the bottom, I'm just pasting the GitHub repo for our screenshots, code and customizations. Feel free to poke around any other repos that we have on there as well. So now I want to talk about data storage. as I said, the core tool for data entry for our volunteers was Google Sheets. So let's say now we have all of this data that we collect very carefully with our eyes and our hands. Where does it go? So this part of the talk is going to involve a lot of our feelings about Google Sheets. So a couple more details on our data entry process. During data entry shifts, lots and lots of volunteers would scour state and US territory dashboards. Then everyone would write the findings into a giant Google Sheet that I showed you earlier, which we called Worksheet 2. No one talks about Worksheet 1. There's also lots and lots of metadata attached to every state, and everything is ultimately stored in a bunch of interconnected sheets. So in general, like many other aspects of the COVID tracking project, work and organization, this process very much had to evolve as we went. We did a lot of building the plane as we were flying it, because change is the only constant. So Google Sheets is fantastic in many ways. It's an awesome tool for collaborative data entry, especially for data structured as a table, which ours was. It's generic and flexible enough to accommodate folks with different backgrounds and kind of different levels of tech savvy, and respond to different circumstances, like lots of types of data changes, which came up a lot. And then lastly, the tabular format of our data was very much baked into our data entry process and pipelines, every step of the way. So all of that meant that for a long time, Google Sheets was our world for anything we needed. And we had pretty awesome tooling within Sheets to make all of these things possible. This was a mix of Google Apps Script, Magic, and lots of Excel type power usage. And all of this powered very kind of domain specific data collection and publish processes. So using Sheets for data entry was awesome. The problem was that in the beginning, we were also using it as a data store for time series data, which was less awesome because we started running into a bunch of issues. So first of all, our data just got too big. We were adding 56 rows and an increasing number of columns at least once a day. And because the project ran way longer than the few weeks that we originally thought that we would need to do this for, this ended up pretty quickly. So the performance of Google Sheets started degrading with this much data and this many people trying to edit it at the same time. We also ran into issues around accidentally losing edit history if a cell got deleted, and with a lot of volunteers, this kind of thing is bound to happen at some point. Rolling back mistakes was hard because all of our tooling was dependencies coded within the space of Sheets. And problems like this were also getting harder to prevent within Sheets because as our data got more complex, so did the problem of validating it. So we ended up adding a database layer that took a bunch of the data store and data validation pressure off of Google Sheets. The challenge here was adding a critical piece of infrastructure in the middle of a production data pipeline, basically amounted to building one plane while you're flying it, and then building a second plane while you're flying it and trying to hook it up to the first plane mid-flight with no interruptions. So those kinds of changes are never easy, but it was worth it for the separation of concerns between data entry and data storage. So it's a brief overview of our stack. On the left, we set up a Postgres database on Amazon RDS. The data in this database became our published source of truth. We also had an internal API layer, which I'll talk about more in a minute, but ultimately it supported both reads and writes, and it was the only programmatic route to the database. So this was a Python Flask app that was heavily built on top of SQL Alchemy that sat between the database and our spreadsheets. And this API layer took care of transforming and validating incoming data, both from our kind of main data entry sheet and also other sheets and scripts that we built over time to support the data editing process. And this internal API would also transform the data to feedback out to our website and our public data API, which I'll talk about a little bit later. And then I also wanted to say a couple of things about the way that we represented our data. So first of all, each metric was its own data column. It's very straightforward. It's easy to visually scan, less error prone to query that way. And it's also similar to the mental data model that we kind of collectively built up over time. So this let us keep the data store itself as simple as possible. And then second, in order to preserve history, we set it up so the data was never modified, it was only added, which I think is a fairly common approach. But the way that we would add the data is through batches. So every single data row was attached to a batch ID. And we could interpret those chronologically and essentially play it forward as needed. So this borrows a little bit from the idea of database transaction logging, except applied on the data modeling level. So for example, if we had to go back and revise our data for some state and some date in response to a state data revision, we would then know that the newer batch, higher batch ID, is the data that we should treat as currently accurate. But since we stored all of it, we could also trace these changes over time. So Flask and SQL Alchemy worked really well for us here to let us enforce correctness both on incoming and outgoing data as part of this kind of internal API layer that did all of the heavy lifting on data transformation and semantics. So this meant that our columns are simple, our rows are simple and associated with batches. And then the last thing that I want to note here, we chose to take complexity out of SQL queries in this case. That would have been another option for enforcing data invariance. But instead, we decided to keep our SQL queries simple and then move that kind of logic largely into Python, where we could iterate and filter through all of our data in a way that was more readable, less error prone, and also easier to unit test our logic, which was pretty important. So overall, keeping the data store as simple as possible was our friend in this. And having a model that was a combination of simple data representation, but then a layer that would transform it as necessary for the different use cases worked pretty well. And as kind of a more general point, all of our tech at CTP ended up being, on one hand, generic solutions, on the other hand, pretty custom and scrappy. But on the third hand, we still had things like unit tests and code reviews. So from the engineering standpoint, this was a pretty cool balance to strike. And on the right here, this became an emblem of our database project with spreadsheets and data. This was a brilliant work by one of our volunteers. So the last thing that I want to talk about a little is how we shared and contextualized the data that we collected. So I mentioned before that we had a public-facing data API. This went through several iterations over the lifetime of the project. V0 was straight up a public Google Sheet that reflected the structure of how we collected the data. Once that stopped scaling, which was 5 minutes later, we built a V1 of the API, which essentially served out flat CSVs and simple JSON files. These were basically just key value pairs for, at first it was testing and outcomes metrics, and then it was all of our data. And then eventually we, fairly late into the project, but we put out a V2 of the public API, which was structured JSON files. So we used what we had learned about the data over time to organize it a little bit better. So things like nesting related metrics, like grouping all tests together into a top level test category, and then breaking that out further into like the type of COVID test performed, like PCR and antigen and so on and so forth. It also let us add things like derived values, like smoothing the data over the last 7 days, structure the metadata a little bit better, and metadata was a big part of the project as well, so on and so forth. So V1 and V2 of this public API, these were effectively a caching layer on top of our data that was backed by GitHub static files. So easy to store and serve. Scalability was a big concern for us, given that we were eventually fielding millions of requests per day for this data. So aside from making the data itself available, our group tried our best to use the experience of staring at these numbers every day to contextualize the shifting data definitions and the data itself. We were not data modelers or epidemiologists, but distinguishing true anomalies from data artifacts became a really important part of what we tried to communicate. So as an example of something where context was really important, a state might suddenly receive a large data dump of positive cases, which would not actually reflect that day's data, but it would appear as a scary spike on the time series. Or a state might change the definition of some metric, like how exactly cases were being counted. So overall, the science communication and editorial components of the COVID tracking project became really important to us over time. We published daily tweets, giving a data update with context as needed, and a lot of blog posts, a lot of blog posts going into more detail about the data that we are working with. Those are all still up on our website, covidtracking.com. So CTP was a completely incredible effort to participate in. Eventually, our data came to be used by a ton of people and organizations. We're cited in a lot of papers and news stories, and even some congressional reports, which was pretty amazing. Seeing policy changes as the result of making this data available was an incredible thing. So this was a really profound learning experience to be part of this org, for me, at least, I think for all of us. But one of the many reasons for that is as we grew, everything had to scale at once. The number of volunteers and our processes and our tooling and all the things. So I just want to end with some data related takeaways that have been helpful kind of for me to think about and carry forward. So first, it's very, very important to stay connected to the data. Data without context is meaningless. Lying with data is very easy. And depending on the nature of what you're working with, you have to get your hands dirty and keep them dirty in a sense to trust what you're putting out into the world. It's also important to think about data storage and representation as early as possible in the lifetime of a project. Infrastructure decisions that are made early on will strongly influence what happens later, both in terms of technology and in terms of process. In our case, the early choice of Google Sheets had a pretty strong and persistent impact on our workflow. That sort of thing is tricky to change later, but also it's important to be flexible. So in a project like this, where things change all the time, we had to be willing to adapt our processes and our tooling, which is also related to not automating things too quickly. Automation is a really good goal to have, but it's one where you need to learn as much as possible about the space that you're operating in order to make sure that you're automating the right things at the right time. So very, very, very importantly, CTP went from just a handful of folks in the early days to over 800 volunteers in data entry, data quality, outreach, reporting, infrastructure, communication, visualization, the website, other teams that I'm not even remembering right now, but people donated 20,000 hours of time just in data entry alone. And I'm incredibly grateful for the heart and soul that went into this project and the ways that people helped each other out. By the nature of the work that we were doing, this was a really intense time for many people. We were watching and collecting numbers at the same time as everyone was also living through it. But we didn't want the organization to be a grim place to show up to every day. So people found a ton of ways to be creative and kind and funny, like that database emoji that I showed you earlier. We actually had a really strong emoji culture at CTP, but either way, this work would not have been possible without this community. I'm really grateful to have been a part of it, and a giant thank you to all of our volunteers who made this possible. Thank you so much for listening. Happy to take any questions you might have. Also, feel free to reach out to me on Twitter as well.
Thank you so much, Julia. What an interesting talk. I'm watching here the chat for questions. Any questions? If not, I have one. This is a giant project that was rapidly evolving. And how did you govern this project?
So you mean like what my personal connection was?
No, I mean, like, how do you govern a project that evolves that quickly with that much data involved, that much web scraping?
Sorry, do you mean like how you, sorry, I'm actually not sure I heard your question.
Yeah, like how often do you meet? How do you do this? Like who makes decisions?
I see. So honestly, the decision framework on this project was also something that very much evolved over time. I think when it was just a few of us, everything was, things were happening really quickly. Everyone was kind of doing everything. Like I initially started as just, doing data entry on the project too, to kind of get a sense of what we were even doing. Eventually, not even really that eventually, but the project gained a lot of volunteers really fast. And so we ended up structuring our processes at the same time as we also started structuring our teams. And I would say that every team, depending on the function within CTP, had a different cadence for meetings and how work was structured. So a team like data entry, which also had the most volunteers, that was by far the thing that needed like the largest number of people and the largest set of eyes and human time on it. Their work shifts were incredibly structured, and people would sign up for shifts in advance. We eventually came up with a training program. Like we had data checkers, we had double checkers, and like that was structured and at the same time every day until the shift was over. Whereas on a project like infrastructure, a lot of that was, that probably looked a little bit more like, if a startup starts remote first and everyone just sort of figures it out as we go along. The cadence of work there, we didn't have to have shifts, but we like instituted code reviews. We instituted sort of like the basic building blocks of how do we all write a bunch of code together without everything crashing at the same time. So yeah, I would say that varied quite a bit between teams.
Okay, and I have to apologize here. I just saw that there are 1 million, okay, less than 1 million, a lot of questions though. So I'm going to go with them in order of arrival here. Adam asked who initiated the project in terms of leadership and authority.
So the project came about because there were two people that had known each other for a long time, that both started putting together Google spreadsheets without knowing that each other was doing it. And then they connected about it and found out that this was a thing they were both tracking. So Alexis Madrigal, who's a journalist of The Atlantic, and Jeff Hammerbacher, who's done a ton of work in the data space in general. Initially, they both started tracking testing counts. So in early March 2020, no one was counting tests. There were some people that were sort of attempting to count cases, but the extent to which cases meant nothing in the absence of the context of how many people we were testing, that was the original impetus. So that's also why the start of spreadsheets. And then, like I happen to know Jeff, so that's actually how I got pulled into this project to start with. We'd worked together before. So initially it was not a lot of people. And then I think over time, lots of coders and data people, and really anyone who was watching this and felt powerless to do anything, found a thing where there was like something we could do, which was to write data in a spreadsheet. So that was sort of the genesis of it.
Okay, and thank you. We have another question of a user who goes by MMCANEAR. Great presentation. Thank you very much for the deep dive. How did you verify that the screenshots were always of the data you thought you were capturing over time? And this is also the last question for today.
Absolutely. So that actually became, as I mentioned, screenshots were best effort in part for that reason, because what you're saying is true. It's actually pretty hard to verify that. We ended up building that into our data entry processes. So every, I want to say it was weekly, but I'm not sure I'm remembering that right. But I think about once a week, we actually would have a shift of folks who would go through and just like go through the state, the kind of state of our screenshots, see which ones were stale, see which ones didn't work, see which ones needed a longer timeout, what have you. There were ideas that we tried and did not go for, like trying to figure out, like doing any sort of ML to figure out if, like, let's say today's screenshot differed dramatically from yesterday's. I think this was a thing that was like sort of half-heartedly attempted, and then we dropped it because the time trade-off wasn't worth it, just given the structure of the organization. But yeah, that was another thing that ended up being kind of sort of manual.
Yeah, thank you so much, Julia, for taking the time to present to us today, and thanks for being part of PyData Global 2021.
Thank you.